Afternoon, students. How are you doing?
Evening, sir. We're doing fine.
Good, 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 good. right? Based on the number of students I think I have in my class, at 13, I am at 9. Well, one just came, I'm at 10, so there are 3 students that are absent. Um, Let me see if I can figure the 3. Roger is not here. Demoy is not here. Hmm. I can't think of who is. Okay. So, no, Roger, Demoy. And that could be 13, that could be 14. Somebody else is not there. Who is it, Lord? Hmm. Okay. All right, I am about ready. Where will be the last time, please? Can you send someone remind me? Oh, partial derivative.
They're doing the simultaneous stationary point like question.
Yeah. Okay, good job. Thanks much. So we're still on the partial derivatives. um, okay. And we have done the cross order partial derivatives, right? Hello?
So we had cross order.
We've done the cross order partials, right?
Yes, sir.
Mm-hmm. I know they didn't want to answer me because they don't know what is cross order partial. Can you tell them what his cross order partials are for me, please?
It's when we differentiate y what's that word, to the f of x y or yx.
Okay, and is a cross order partial a first derivative or a second derivative?
A second derivative, sir.
Very good. Thank you very much, Rayton. So you are correct. You'll get an extra 0.5%. Very good. So the cross order partial derivatives are those x, y, y, x calculations, and they are a second order differential that we're doing. So we've done our differentiations. What I can do, what I think I should do is, because I know, let's see who is this. I was trying to remember who else is missing. Let me just see who came in just now. Demoy is here, but there are 2 other students that are absent. We have, we are looking at, we're looking at the second order, the stationary point of a multivariable function. But I think the last time, it was last Monday, if I'm not mistaken, did I do like a past paper question with you, or what did I do exactly?
So we'll work one example to first. You can show a question, yes, sir. Either work one example. And then you have
Mhm.
C.
You're going through the steps, but I don't believe you had completed it.
Say it again, Papa.
You're going through the steps, sir. So I think I have up to step 2. I'm not sure if that's exactly where you stopped.
So I was going through the dictionary point steps.
Yes, yes, sir.
Okay, thank you. All right, so that's what I'm looking at, and that's what I remember. All right, so I'll just go from, I'll just pick up from there, and then I'll give you a question to work as a refresher. So let me just refresh your memory. All right, so it's now 23 past. I'm officially going to begin. There's one other person that is missing. Can't pick up who that person is, but Rajian and Demoy, who don't say good afternoon yet, have joined. But so stationary point. So remember now to determine the stationary
Sir.
point. Afternoon, Papa. So to determine the stationary point of a multivariable function, we are going to differentiate the function f of xy. We're differentiating the function f of xy. And when we differentiate the function f of xy, we should get 6 things. Always remember. Oh, how could I forget, Alwyn? Jesus. We should not forget to talking foolishness. We should calculate 6 things. There are 6 calculations that we should have. F of x, f subscript x of xy, f subscript y of xy, f subscript xx of xy, f subscript yy of xy, f subscript xy of xy, and f subscript yx of xy. So once you get the question, run those 6 calculations. Once you see the multivariable function question, talk about stationary points and then something there, run those 6 calculations because we're going to be needing all 6 of them. We're not going to use all 6 of them up front, but eventually we're going to use them. So let's go. So we're going to differentiate the function. And when we differentiate the function, we're going to obtain the value of f subscript x of xy and f subscript y of xy. Then we are going to set the differentials, the first order partial differentials, to equal to 0 and solve those simultaneously or otherwise. So what do you mean by otherwise? Sometimes the equations that you get are standalone, so you can work equation 1 independent of equation 2, or equation 2 independent of equation 1. So if you're given a situation where you can work one of the equations independent of the other, you work that independent function first, and then you can substitute it into the dependent function, and then you'll be able to get your critical points. Critical point or critical points. So you have your critical value or critical values. All right. Then the third step is that the results will yield, of course, the stationary points, the critical points, the turning points. All mean the same thing. All right. And then now to classify the nature of those stationary points, to classify the nature. Suppose that you're given AB is a critical point. So what do you mean by AB is a critical point? You're given a value. And say the value that you're given is A, B. For example, like 1, 2 or 3, 5, the critical point. Then it is going to be the critical point of f of xy. And that the second order partial derivatives are continuous on some region that contains the critical point if D is going to be equal to f of xx ab times f of yy ab minus f of xy ab all squares. So this function is going to be very critical for you to to determine the nature of the critical points. To determine the nature of the critical points, you're going to have f of xx ab times f of yy ab minus f of xy ab all squared. Remembering that your f of xy is going to be or should be the same thing as your f of yx. And that's why we square it. So both of these values are supposed to work out to be the same, and that's why we square it. So if these two values are not the same, we can't square it. So both values must be the same, should be the same based on the calculation. Then we're going to have the following classification. Now, f of xxab is, I'm going to be looking for the second order partial derivatives of x. And wherever in the function I see x and y, I'm going to substitute my ab, which is my critical value, in order to get a single value for this f of xy, f of xx. I'm going to be doing the same here for f of yy, and then I'm also going to be substituting that singular value in order to get that function. So I'm going to multiply those two numbers, and I'm going to do the same thing for my f of yx. Now, when I do this calculation, if d is positive, then I must look at f of xx. If f of xx is also positive, then I have a relative minimum. So if d is positive and f of xx also has a positive value, then I'm going to have a relative minimum. If d is positive, but f of xx, when I look at it, is negative, then it tells me that I have a relative minimum. You see, once d is less than 0, we have a saddle point. D is less than 0, we have a saddle point. D is less than 0, we have a saddle. If d is equal to 0, we send back the question and give them and tell them, say, yo, I need other techniques in order to find a critical point. Return to sender. So what I say to you is that none of the questions that I will give you, because I don't want you to return the questions to me, you will get d to be equal to 0. So if you do a question and get d equals 0, you know you're not right, because I'm not going to give you something with d equals 0. So let's go again. If when you evaluate your function, and d works out to be positive, if d works out to be positive, you know you can't have a saddle point, because the saddle point only occurs when d is negative, right? The saddle point only occurs when d is negative. So once d is negative, you know, boom, I have a saddle point. But if d is positive, you can have a relative maximum or a relative minimum. You don't know which is which just yet. You now have to look at the value of f of xx. If f of xx is positive, it means that you have a relative minimum. However, if f of xx is negative, you have a relative maximum. F of xx is less than 0, and number less than 0 is going to be negative. You're going to have a relative maximum. At AB, which is at the critical point, if f of xx is greater than 0, which means that it is positive, then we have a relative minimum at AB, which is at the critical point. Am I clear?
Yes, sir.
Are there any questions to that? Thanks, Taj, for responding. Any questions?
No, sir.
That's it.
Okay, not yet. And I like that. I like that. Okay. All right, Mr. Battery. What on the wall? I have a question for you, please, before I move into something else. It's a concern of mine. And I think maybe you guys are the best ones to tell me. Is there anything that I can do to boost a battery life on a computer? I mean, you know, I am yet to find a computer that I can have 2 hours of classes using Zoom that I don't have to charge. What can I do to boost my battery life? Is there anything?
Nothing.
Say it again.
Nothing.
No, sir. Sir, how long
You
you have
mean-
how long you have your computer, sir?
It just by like last year.
Just why?
Yeah.
If
Ah.
it was just last year, it depends on your usage. And for a lecturer, knowing that you have classes maybe from the morning up to now is like to sure the battery will go
No,
event,
man.
the play.
Tariq, it's like before I have, okay, so if I'm having your class at 5 o'clock,
Yes,
I'll
sir.
have like a full battery and like an hour, 20 minutes or hour, 30 minutes into the class,
Yeah.
I have to charge. And the thing about it, I thought I didn't want another HP because I thought it was also HPs. But my other colleagues are also complaining, you know. So the point I'm making, if I'm on the road
Yeah.
and I'm having a class, I can't have a 4-hour class. Because clearly, if I can't have a 2-hour class, I can't have a 4-hour class. So if I'm on the road, I'm trying to have a, say for example, something happened and I have to be on the road for 5 o'clock, and I say, you know
Yeah.
what? I sit in the car and have a class with my students. If I don't have a battery source, it make me
Sure.
kind of down.
Yeah. Me?
So what I've done is to cut a battery pack that I have that the computer can actually plug into it, and that
Yeah.
gives me about a half an hour, you know, go. But sometimes I forget to carry it. But I don't know. So there's nothing I can do. That's what you're saying, right?
Yeah. Well, here to the Apple devices have some good battery life. I don't know if anybody can have a second say on
So
that.
you can buy a MacBook Pro, sir.
Yeah, MacBook normally have good battery life. DJs, people who play music normally use MacBooks, and they them play music for a good while. So yeah,
Yes, you can
know
the
what
latest version.
but
you know one of the things that
expensive. But,
you know what Tariq, that's exactly what I was about to say. You know, one of the things I like about Kenneth, he's very confident that I can afford a MacBook Pro, and I just love that about him. Thanks, Kenneth.
who believe
Of
it,
course,
sir?
yeah.
I believe it too.
You believe it too, Tariq? No, man. Thank you, Tariq.
Yes, sir. I believe you can afford one. Remember,
Right, and I hear you.
you're going to the conferences, you know, sir. So
Yeah,
just
and that is
just
sometimes at my expense so that I can be a better teacher so I can help you. Good.
yes. Apple device gonna make a better one. Just trust it.
All right, I hear you, Papa.
Yeah, man.
One of these days, one of the things that I want to invest in though, to see if it makes a difference, because I was actually looking at one of those is the iPad Pro. I don't know if I want to go to the MacBook, so I was really looking at the iPad. But yeah, so you know, it's that I am torn between cellular and Wi-Fi, or just Wi-Fi alone and everything else. And right there is 1,002 plus case and plus everything else. You're looking at about 1,005.
Yeah.
So you know, all right. Thanks for the info. All right, what I'm going to do for you now is I'm going to give you a function that you're seeing on the screen now. It says do now. And I'm going to give you a simplified version at the start of it. And then I'm going to complicate it somewhat. Actually, it's a complicate because it's going to be the same types of function. But one of the things that I want you to recognize, and I think I need to point it out at the top of this class. So the solution to this question is going to be something similar to what I expect you to get on your exam. And I should let you know, don't tell anybody that I tell you, but our vetting of the examination papers begin. And you know, come tomorrow, we'll be vetting these exam papers. I'm very sure, positive even, that you're going to be getting a question on the final exam on this topic for 30 marks. Very positive. Now, one of the things that I'm even more positive about is when you see the solution to this question, it's going to be the same thing that is going to be repeated for the calculations for the other question. However, other questions. However, the simultaneous aspect of it may be tricky in the other one. I don't think it's going to be as straightforward as the one that we're doing here now. If it is straightforward, it means that the question may be like about 15 marks or at most 20 marks. The question has to be a little bit more heavy or heavier in order for them to give a 30 mark. But so after this question, I'm going to show you what an exam type question looks like. And then I'll do some questions, some past papers for it, on it. So do me a favor. You have your multivariable function. I'm going to give you about 4 minutes, 5 minutes to do the 6 calculations for me. Your f subscript x, 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 y, 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 x, y, and y, x. Quick and fast.
Finished, sir.
All right, guys. I'm only seeing one answer that came into me, but let us see if we are where we're supposed to be. Alwyn, how you stay, pops? Give me f subscript. What is the value of f subscript x? What's the function for f subscript x? All right, Alwyn not there.
Sure, yeah, hear me now.
Oh, hearing it now.
Yes, sir. Okay, because my laptop kind of a bit low, so repeat now, please.
F subscript x. What is that?
F subscript F subscript X.
Mm.
2x plus y.
Is he correct?
Yes, sir.
Okay, all right.
Yes, sir.
But
Sir, also, I realized that because I wrote it in my book and then I typed it out, I made a mistake. There was supposed to be a +1 with
I am going to
subscript
charge you. I'm charging you.
Sir, I have it in my book. I wrote it in my book. I just
I know.
made a mistake when I sent it to you.
And you shouldn't make no mistake. So the mistake didn't cost you $1,000.
All right.
All right, then
sir.
good. All right. So yes, Carno, I'm seeing yours to be x plus 2y plus 1. Taj left off the 1 and the 3 zeros, so he's going to be paying $1,000. But yes, that's correct too. Very nice. Proud of you. And then now let me see if I can call up on Shane. Give me the value of f subscript x and f subscript y.
Sir, for both of them, I got 2.
Is he correct? I didn't get 2.
I got
Yes, sir.
2, sir. He's correct.
Is
Yes,
correct?
correct.
Yes, sir.
All
Yes,
right,
sir. Yes,
good.
sir.
I think I saw where I went wrong. And who should I call upon? Dujon, what did you get for f subscript xy and f subscript yx? Dujon is not there. Won't be waiting. Hamilton, what did you get? You're not there either. Won't wait on you. Damoy, what did you get?
For F subscript Y.
No, sir. F subscript yx and f subscript xy.
Oh, one for
For
both.
both?
Yes, sir.
Do you agree with M class?
Yes, sir. I agree.
Yes, sir.
Yes, sir.
And so do I. I agree as well. Look at those for me, please.
So if you're talking, I might be.
No man, I was just giving you guys some time to look at it because I called upon a few people and they didn't respond to me. So I don't know if they were having some challenges. So I was just giving them some time. So let me go now. So based on what it is that we did in the setup, what we said that we're going to be doing is to set our f subscript y and f subscript x to be equal to 0. So I'm going to say 2x plus y equals 0. See it down here, let me spotlight so you can see what is happening. This is 2x plus y for f subscript x. See it here, 2x plus y, I'm setting it equals to 0. And then I'm going to have x plus 2y plus 1 equals 0, which is here. Now I have two equations in two unknowns. I'm going to solve simultaneously. Two equations, two unknowns, I'm going to solve simultaneously. Now, my simultaneous solution is going to be setting up my equations this way, one atop the other. But normally what we do is to keep the two variables on one side and the constant on the other side. So I am going to be subtracting 1 from both sides from, all right, I use a different method to solve this. Let me see how many of you remember how to do the elimination method. I'm going to write the elimination method on you, so I have to go and grab my tablet. So I want you to solve this pair of equations for me simultaneously. Guess what? Matter of fact, you know, Sam, I shouldn't even be doing this, you know. You know why? Because we did simultaneous equation when we're doing piecewise functions for calculus 1. So you all should remember how to do simultaneous equation. Can I solve this pair of equation for me, please, simultaneously? 3 minutes.
Sir, help me, please.
Say it again.
Sir, help me, please.
Hey, hey,
Sir, I want to hear since the calculus one, please. Do,
hey.
help me.
Tarek, dig deep down into the reservoir of your knowledge. All right, give it a try, Tariq. And the rest of you should have it ready for me because you did piecewise just last semester, a couple months ago. 3 minutes, and then I will try and bail out those who need to be bailed out.
Where am I done? But I don't know what I'm going for this. I look right. So I'm not sure if I use the elimination method correct.
But we not understand, Andrew. Let me just check to see. All right. Yeah, English self pop up. Let me give a props to the Andrew.
Right?
Well, you're going with things before. All right. All right, so, I'm seeing those messages, guys, and when I come to classes like this, when we're doing revision, I'm going to honestly ask you to put up your $1,000 before I continue, because you guys are taking this thing from my tour. The more I'm starting with you, because I don't understand. When we did this last semester,
Sir,
the more
kinda,
we not we don't want to
I
excuse
kinda
from
don't
the
remember. Sir, but I'm looking back because it's the same book I use. So I'm trying to look back, try to understand.
You're not trying hard enough. All right, let's
Yeah,
go.
sir.
Let's go. Yeah, never mind. Let's go. So I hear you guys, and um I see the stuff. I see the difficulty. I think the difficulty is going to be with solving the simultaneous equations. And we have to overcome this difficulty for this question. This is 30 marks. I mean, we're spending a bit of time on this. This is March. I have to finish the syllabus pretty soon. So I can't spend too much time on this. So what I'm going to do, I'm going to rewrite. Let me just take off this thing because it annoys me when I'm writing on it. So I'm going to rewrite equation. I'm rewriting equation 2. And I'm going to let equation 2 be equals to x plus 2y equals to -1. Can you see that? I'm transposing it.
Oh, yes,
Can you
sir.
see that? Good. So I'm just subtracting 1 from both sides. So my equations now are 2x plus y equals 0, and x plus 2y is equals to -1. And I'm solving those simultaneously. And I'm using the elimination method. So if I want to eliminate, I want to eliminate y's first. You will remember and recognize that the coefficient of the y's are different. I have a 2 here, and I have a 1 there. So in order for me to eliminate, oh, sorry, this is supposed to be plus. I erase something. In order for me to eliminate my y's, you'd agree that I have to multiply here by 2 so that I can get both y's to be the same, of the same coefficient. So if I say 2 times 2, I'm going to get 4x. And 2 times y, I'm going to get 2y. 2 times 0 is equal to 0. And of course, I'm going to write back my other equation to x plus 2y is equal to -1. So now, go ahead.
I did all of that except to the transposing of the 1. So I'm just looking to see why you had to do that, because you could multiply just the same and eliminate the y's before even doing that.
Okay. All right, no problem. No problem. No problem. You soon see. And then now, I'm going to call this equation 3 from up top here. And because I multiply this equation by 2, I'm going to call this equation 4. So what I'm going to be doing, I'm looking for the equation that looks bigger. And equation 4 looks bigger than equation 2. So what I'm going to do is to say equation 4 minus equation 3. 4x minus x equals
3x.
2y minus 2y equals
0.
0 minus minus 1 equals
-1. Negative 1.
equals
Sir, positive one.
positive
Positive
1. Positive 1. And then I divide both sides by 3. Hold on a minute. So x is going to be equals to a third. Put x equals a third into any one of the equations. Call it equation 1. I always like going back to the original equation. So I'm going to have 2 times a third plus y equals 0. 2 times a third is equal to 2/3. 2/3 plus y is equal to 0. I want y to be the subject, so I'm going to say y is equal to negative 2/3. And that is going to be my answer. So x is going to be equals to 1/3. And y is equals to 2/3. Any questions?
So, yeah, so I'm gonna do it, but do it next year and get the answer without doing this some long way.
Okay, it's not a matter of a long way now. This is the elimination method. If I was doing the substitution method here,
Yeah, that me too, sir. That one. Second substitution.
I would transpose this equation to give me y equals 2x, negative 2x. And then I'm going to put y equals negative 2x into the second equation. So anywhere in the second equation I see y, I'm going to put that negative 2x. And then I'm going to distribute. So I'm going to have x. This x comes back right here. This x comes back right here. And then I said 2 times negative 2x gives me a negative 4x. Plus this one, which is right here, equals 0. And then when I say x minus 4x is going to be equal to negative 3x plus 1 equals 0. Then I'm going to transpose. Oh, man. So I'm going to say negative 3x is equal to negative 1. Divide both sides by negative 3. And then x is going to be equal to 1/3. That's what you did, Tariq?
Yes, sir. That's what I started to do.
Right. So this is the substitution method. So you have well, there are several methods to solve simultaneously. In this case, you could use the elimination method, or you could use the substitution method. For this type of question, we could use a graphical method, but we are not going to be doing that. We could also use a matrix method, but we're not going to be doing that. So any of the methods that we're going to be using for this type of question would be either the substitution method or the elimination method, right? So you need to know both methods, the elimination method or the substitution method. So continuing, anywhere in the function I see x, I'm going to put 1/3. So that now becomes 2 open bracket 1/3 plus y equals 0, which is what I have here. And 2 times a third is 2/3, and then I transpose, I get that. So my critical point is going to be 1/3, negative 2/3. Any questions?
No question, sir.
Sir, we get lost na 1 point of the elimination method.
Where exactly?
The fourth equation, we get the 4x plus 2y.
Yes, sir. Right. That's it's confusing, sir. Right,
I'm
so
not
yeah.
sure, yeah, I'm not sure where
All
that
I'm doing is multiplying this 2 by this 2x to give me 4x. This 2 by this y to give me 2y. And the 2 by the 0 to give me 0. Why am I doing that? I'm doing that because I want, this is what I want to end up. I'm eliminating my y's. So I want both of them to be the same thing. So when I subtract something from another something, two of them to be the same thing, I then get 0. So I'm eliminating the y's.
Oh, okay.
Mhm. If I were eliminating the x's, what would I do up here? If I were to eliminate the x, what would I do up here? So
So
So you multiply by 2
by
or
negative
1.
2.
You multiply the second equation by 2.
good job, Alvin. Yes, Tariq, I hear you were coming with the same thing. Yes, I would have multiplied equation 2 by 2 to get this 2x down here. All right.
If you use equation 1, you multiply it by 1.
Very good. Very good. All right, so let's go. We have to use our formula now, remember? Having calculated our y to be equal to 2/3, we have to remember our formula. D is going to be equals to f of xx, xy. What is xy again now? It's now going to be equal to 1/3 negative 2/3. Times f of yy, 1/3 times negative 2/3, minus f of xy, 1/3, comma, negative 2/3, all squared. That's what we need to look at in order to determine the nature. In order to determine the nature. Can you recall what f of xx was again, please? F of xy was equal to what again?
1, sir. The
And
xy?
f of yy equals?
No, 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 no,
Oh,
no. F
no,
of
wait,
XX,
sorry,
F
sir.
of XX
Sir.
Sir,
is
it's
2.
2. 2.
2.
Both of them
2,
same.
sir.
Number
And
2.
f of
Both.
yy?
2.
2.
And f of
Also
xy?
1, sir.
1.
Good. So D is going to be equals to f of xx. You notice I don't have any x and y values here, here, or here. So I don't have anything to substitute in. So all I'm going to say is 2 times 2 minus 1 squares. 2 times 2 is 4. 1 squared is 1. 4 minus 1 is equal to 3. Is that a positive number or a negative number?
Positive.
Very good. So it's either relative maximum or relative minimum. Is f of xx positive or negative?
Positive.
So we have a relative minimum.
Wait, sir, me that right. So,
Say it again, sorry. You're what?
sir, me that right. I just move off everything off the screen.
I don't move off everything off of the screen. I just come down to show you same. And the same thing I have right there. So the same thing I have up there, so it's the same thing I have down here. So
Oh, okay. All right, done, sir. Okay.
problem. Are there any questions? Mark, I'm going to give you one simple one like this to do on your own. And then I'm going to go to something that is going to be of the type I expect you to get in the exam.
Sir, can you scroll up back just a little bit, please?
Sure. Here?
Just a little bit more. Let's see. Yes, sir. That's good. All right. Thank you. That's good.
All right, no problem. All right. So the rest of you, I'm asking the question. The rest of you, I think, to be honest, the hiccup that I'm going to be having with you for now, because I don't expect it to be for far too long, is just the simultaneous. It's just a simultaneous.
Yes, that's
Hold
just
on.
my sir.
We will overcome. We will overcome. Every time I teach this topic, it is what it is for now, but the students eventually overcome their difficulty. Suspecting that you too will do the same. All right, I want you guys to be very diligent. Now, hear me out. Me no want no AI. Me no want no online search. I'm not impressed by those. I want you to try this on your own. Let me just walk you through the stuff again. Once you see the question like this, f of x, 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 y, so forth and so on, you're going to do your partial derivatives. Your 6 of them. Once you get this, make sure say them 6 are something right, because trust me, you get about 5 marks or 6 marks for those early calculations. So you want to start banking some marks as you start doing the question. The next thing that you're going to do is to set your first partial derivative or the partial derivatives to be equal to 0. That is your f subscript x, your f subscript y. You're going to set those to be equal to 0. Once you set those equals to 0, you're going to solve them simultaneously. Spend some time on the simultaneous equation. Double check your I showed you how to double check already. Double check your simultaneous equations to make sure that they are correct, that the answers fit both equations. Once it fits both equations, you know you're correct. Then what you're going to be doing next is to substitute it into the formulation. D is equals to f of xx AB times f of yy AB minus f of xy AB all squared. There you go with another question. I'm going to give you a few minutes. Start working for me, please.
Sorry, not to get off topic, but at the end of the class, you will let us know about when we get the midterm and stuff.
Absolutely. I saw something going around where, and you guys need to advise me, because what I don't want to do is call my mid-semester the day when you also have something. So we're going to agree in class tonight which day is best for us to come in to get the mid-semester done up. So thanks for reminding me. We'll have that conversation tonight. So when we're going to have the conversation, please take out your calendars so we can come to a consensus. The mid-semester paper is already written and ready for you, ready for to be administered. So just let me know. So we'll have that conversation towards the end of the class. Thank you.
Okay, sir. So we have to answer is D. You want?
No, man. Mm-mm. I want you to classify the critical point. Let me know if it's a maximum, minimum, or saddle point.
Okay, sir.
Mhm. How we stay, guys? Are we done with that? Even at least the first bits of calculation?
Yes, sir.
Try to figure out the second part, sir.
All right, so tell me what you get for f of x, f subscript x.
2x plus 3y.
Is that correct?
Yes, sir.
What about f subscript y?
3x plus 2y.
Is that correct?
Yes,
Yes,
sir.
sir.
What is f of xx?
2,
2, sir.
yy,
2,
xy,
3.
1.
yy, xy, sorry, yx3. Okay, good job.
3.
You are all correct. Is there anyone in the class that did not get that? Or those? Talk to me now. Are we all there?
Yes, sir.
Good job.
Sir.
Kenneth, not hearing from you.
Everything has a long time.
Long time. All right, good job. I'm happy about that one. All right, and then now let me check in now. So we're going to set f subscript x of xy and f subscript y of xy equals 0. So can somebody tell me the simultaneous equations, please?
2x plus 3y equals 0. And 3x plus 2y equals 0.
On the screen, everybody has those?
Yes, sir.
Yes, sir.
Sir.
Mm-hmm.
Get my answer. I'm not sure. No, that's my answer.
Okay, I am checking. No. All right, good job, Papa. Very nice.
May I talk, sir?
Yes, I.
All right.
Very good.
Blessings.
Easy, Papa. Easy. Can I get the rum now? All right, so let's go. So so yes, those are the two equations, and we are going to be solving them simultaneously. So let me just go ahead and show you what it is that I did. I'm solving simultaneously. What it is I'm trying to do is to eliminate the x's. So because I'm trying to eliminate the x's, I'm multiplying this equation by equation 1 by 3 and equation 2 by 2. So 3 times 2x is 6x, and 3 times 3y is going to be 9y, and 3 times 0 is 0. And 2 times 3x is going to be equals to 6x, and 2 times 2y is going to be equals to 4y, and that is equals to 0. And I'm going to be looking, remember how sir teach you this stuff? I'm going to be looking for which of the equations looked bigger, and then I'm going to subtract the smaller one from it. So which equation looked bigger to me would be equation 3. Tell me if you disagree or you agree with me.
I agree, sir.
I agree.
Yeah, man. So I'm therefore now going to subtract the equation 4 from it. So I'm going to say 3 minus 4. Watch me. 6x minus 6x is 0. And 9y minus 4y is 5y. And 0 minus 0 is 0. 5y equals 0. That means y equals 0. And what I'm doing there is putting y equals 0 into equation 1. I can put it in equation 2 as well. So 2x plus 3 times 0. Remember, y is equal to 0. Is equal to 0. Let me just pause and say something to you here. In a few of the questions that I've done so far, I have eliminated my x's first. I mean, my y's first. And then get an x answer and then substitute x into the function for y. I did it deliberately this way this time around to show you that I don't have to eliminate my y's first. I can eliminate my x's first and then work with y and then substitute for y to find my x. which is what I'm doing now. So there's no way that I have to do one before the other. So I'm now going to have 2x equals 0. Divide both sides by 2. I'm going to get x equals 0. So x equals 0, y equals 0. X equals 0, y equals 0. And remember now, hold on. Remember now, you have to know that the GRD formula, f of xx of xy times f of yy of xy minus f of xy all squared. You're not getting that formula on the exam. So you must know it out of your head. Recall, what was f of xx again? Hmm?
2.
What is f of yy?
2, sir.
2 again? What is
2,
f of
Yes, sir.
what is f of xy?
3.
So d is going to be equal to 2 times 2 minus 3 squares. 2 times 3 is 4. 3 squares is 9. Uh-oh. D looks like it's negative. Talk truth.
Yes, sir.
Yes, sir.
So if D is negative, what it is?
That's all the point.
Sir.
Once I say D come out to be negative, that's what not more. Don't bother check not f of xx or not f of yy. You don't need to. Once D is negative, saddle point. Follow me?
Yes, sir.
Yes, sir.
Yes, sir.
Is there someone in the class that is not seeing what is happening yet? Okay.
So I need
I
a
need to
third one to confirm.
You know, third one to confirm. Don't worry, but you don't have to ask 2 times. You don't have to ask 2 times, Kenneth. But guess what? The third one is going to be one of the
Homework.
no crazy. You got 20 minutes. I'm using the 20 minutes to do it, but it's going to be one of the types that I'm expecting for the exam. Those were just little warm up. So
So
here goes.
no, sir.
Yes, everybody, sir, you're fully warmed. Here goes. The water boil already. Is just ready to go. Take a quick wash off. The water warm already. Quick wash off. Not cold water, this one. Look at this one. Find and classify all the critical points for the function BAM, 3x squared y plus y cubed minus 3x squared minus 3y squared plus 2. Take your time. It's the same thing we've been doing since last week and today. Do the 6 calculations. So we'll do it in stages together. Do the 6 calculations for me first, and then we'll pause there, and then we'll move on. Quick and fast. Start for me. We're finishing this before 7 tonight. You hear, please?
Sir, how this man?
All right. So I figure that you have now completed the first order partial derivative, second and the second ones as well. So tell me now, what is got for f subscript x?
6x.
Y
Six-
take out 6x.
Y
Say it again.
6xy
6xy.
minus
Oh,
I heard 6xy minus something, but what minus what?
6x.
minus 6, sir.
Good.
6x.
Not just 6, you know, but 6x.
Yes, sir.
Yes, sir.
And then what is f subscript y?
3x squared plus 3y squared minus 6y.
Good job. Does that sound correct?
Yes, sir.
Yes,
Mhm. I agree with
yes,
those.
sir.
What is got for f subscript xx?
6y
Y
minus
take away 6.
Why?
6y take away 6.
xy,
6x.
yx.
6x.
6x.
All right. Sounds like you guys are learning. I hope it's not a fallacy. But very good. Look at the screen. There are some of you that are very silent. There are some of you that I'm calling on and you're not responding to me. But look at the screen. If you have a challenge, raise your hand. Talk to me. Unmute. Let me know what is happening. Are we okay?
Yes, sir.
Yes, sir. It's on the easy part.
Then now what we're going to do is to put my first order partial derivatives now, my x and my y equals 0. So I'm going to have 6xy minus 6x equals 0. And 3x squared plus 3y squared minus 6y equals 0. Do you believe I can solve those equations simultaneously by using the elimination method?
Sir, I'm still do it.
And let me ask you, do you believe we can solve the pair of equations by the elimination method?
No, sir.
No, we can't. What method must be used?
Substitution.
The substitution. All right, so we can't solve it because one equation is linear and the other one is quadratic. So let me go through this with you. So yes, we know that we have to set the first derivative equals to 0. We have done those. This equation is not linear. This equation is actually non-linear. Non-linear because I have an xy, x times y right here. It's non-linear because I have an x times y right here. So one is a non-linear, one is a quadratic. Must be solved using the substitution method. So let me show you what it is that I'm doing. So what I've done is to say, looking at the first equation, we see that 6x is common to both. 6x is common to both. There's a 6x here, and I put it in blue to show you the commonality of it. So I'm going to factor out the 6x. When I factor out the 6x, I'm going to be left with y minus 1. 6x, when I factor out the 6x, I'm going to have y minus 6x from 6x is going to be 1. So we're going to have 6x times y minus 1, and that's equals to 0. Can you see that?
Yes, sir.
So
Sir.
either, go ahead.
Sir, I'm gonna factor on, let me just move the x's to the other side of the equation. I'm still not with the same one, sir.
Did you end up with this x equals 0? Say
So
no.
end up with y equals 6x over 6x, which is equal to 1.
Good. So answer my question. Did you end up with that x equals 0? Just tell me no, I don't know, Andrew. Talk to me quick and fast, no, man.
Yes, sir.
No, good. So that's the point I'm trying to make. That's why I asked you the question. So let me just go down here, so, and say that I don't want you to do this. I don't want you to carry over anything like what Andrew just did, because you're going to lose one of your answers. So if you do like what Andrew did, you're going to lose one of the answers. I don't want you to do that. All right? So what he did was to say 6xy minus equals 6x. And then what Andrew did, you said 6x over 6x. Those cancels those. This it goes one time. So y is equals to 1. That is correct. But all he got was y equals 1. He did not get this x equals 0 because of the method that he uses. You cannot afford to throw away your values like that. So I don't want any cancellation. However, what he should have done is to factorize, and then he would have ended up with 6x equals 0 and y minus 1 equals 0. And then he got this y equals 1, you know. But he should have also gotten that x equals 0. So hear me out. Note, always factorize and resist the temptation of canceling the x's. Please note that these are not critical points yet. They are only critical values. This x equals 0 and this y equal 1 is not critical points. They are critical values. But importantly is this. Or else you're going to end up like what Andrew ended up with. Just one answer. X equals 0, y equal 1. So Andrew will come out to the exam and say, yeah, man, I shot that, man, I get 30 out of 30, because guess what? Everything come out straight. And then when Andrew seen good, and he said, sir, why me get 15 out of 30 for the question? Only 50% me get, sir, 100% me supposed to get. Yes, Papa, but you know, when they do the part. So always resist the temptation of canceling. Always factorize. Am I clear?
Yes, sir.
Yes, sir.
So now, I have two critical values. See? Those are my critical values. So, I'm going to put my x equals 0 into my f subscript y. Please note, I've already used f subscript x. I must now use f subscript y in order to finish off my calculations. So I'm going to be making the substitution. Anywhere in the function I see x, I'm going to put 0. Do you now recall at the top of the class when I said to you that sometimes you solve them simultaneously, sometimes you solve one equation and then use that one equation to substitute to get the solution for the other equation? Anybody remember me saying that?
Repeat, sir.
I said to you sometimes, how you're going to solve your simultaneous equations, you may be able to solve them using the elimination or the substitution method, but in some other cases, you can solve one equation and then substitute it into the other equation in order to complete the simultaneous solution. Sometimes you're not going to get the solution to solve at the same time. You have to solve them one independent of the other, which is what I said. Can you now see what I'm talking about?
Yes, sir.
So equation 1 was solved independent of equation 2. right? It's what's called independent of equation 2. So look at what is happening here. So anywhere in this equation, I see x, I'm putting 0. So it's 3 times 0 squared plus 3 times y squared minus 6y equals 0. Then I'm going to get 3y squared minus 6y equals 0. And again, do not do this by dividing both sides by 3y, by transposing. You know, you're going to say that 3y squared is equals to 6y. And then we're going to divide both sides by, say, 3y. And then we can get this cancels this, and this cancels into one of this, and this cancels this, and this cancels, and that goes 2 times. And you can say, oh, sir, y is equals to 2. Don't do that. Because it's just one of the answers you can get. You're not going to get the x equals 0 answer. So you can go through again the factorization like I showed you. So that's a no. So say the yes here. You're going to say 3y squared minus 6y. You look to see what is common. 3y is common to both. I can say 3y into 3y, so we go to y times. 3y into that goes minus 2 times. And then 3y is equal to 0. That implies that y is equal to 0. Or y minus 2 equals 0. And this implies y is equal to 2. So I have 2 values of y, 0 and 2. Can you agree with me on that?
Yes, sir.
Andrew, can you see why, Papa, I should not go ahead and cancel but factorize instead?
Yes, sir. I lose one of them. Yes, sir.
All right, good. All right, guys. So we're wrapping up now. The session. Not being able to finish off the question, but I just want to show you the combination of these stuff. Well, I could actually finish off the question. I want to show you the combination of this stuff. Now, remember, I had made a substitution of x equals 0. So my critical points now will be x equals 0 and y is equals to 0. That's one critical point. Or I could also get x equals 0 and y is equals to 2. Can you see the other critical point? Because remember, no, this is my critical value here, x equals 0. And when I substitute it into the other equation I was getting, I got out y equals 0 and I got y equals 2. So the y equals 0 and the y equals 2 are both related to the x equals 0. Tell me that you agree with that.
Yes, sir.
For those of you who don't see it yet, remember x was equals to 0, right up here, so? When I substitute x equals 0 into equation 2, my outputs were y equals 0 and y equals 2. So combining both, I'm going to get x equals 0 and y equals 0. This same x equals 0 and y equals 2. So I'm going to have x equals 0, y equals 0, x equals 0, y equals 2. So x equals 0 produces two y values, 0 and 2. See that?
Go ahead.
You understood how I got x equals 0 from up top, right?
Yes, sir.
So that was from equation 1. Now, what it is that I'm trying to do is to find out the corresponding value. Because remember, x equals 0 is just a critical value. In order to find a critical point, I must now substitute it into the other function. I must now substitute it into the other function. I must now substitute it into the other function. Substitute it into the other function, like I did here, I did the calculation here, show you the calculation right here. I'm getting y equals 0 and y equals 2. What I'm saying to you is x equals 0 is corresponding to two y values, y equals 0 and y equals 2. So when I put my input is x equals 0. I'm ending up with two different outputs. Can you see that?
Yes, sir.
The rest of you, are you seeing that?
Yes, sir. It's right here.
In a similar manner, I know it's 7 o'clock, but I'm just showing you something quick and fast. In a similar manner, y is equals to 1. I'm substituting the value there. So anywhere in the function I see y, I'm going to put 1. When I do that, 3 squared plus 3 times 1 squared minus 3 times 6 times 1. 1 squares is 1. 1 times 3 is 3. 6 times 1 is 6. So I'm going to have 3x squared plus 3 minus 6 equals 0. 3 minus 6 is negative 3. So again, we're not canceling. What we're not doing here is to say 3x squared is equals to 3 and divide both sides by 3 and we can get x squared equals 1. We're not doing that. Sir, but the answer can work out. We're not doing that method. We're not doing that. What we're doing is factorizing. So what we're saying is, what we're doing is to say 3x squared minus 3 equals 0. We're looking to see what is common, 3. We take out the 3. What is left? X squared minus 1 is equals to 0. So either 3 is equals to 0, which is not a no-nonsense equation, not possible. 3 can't be equals to 0 none time. So all I'm going to have now is x squared minus 1 equals 0. We know this to be the difference of squares. X plus 1 and x minus 1. So what we're going to have is either x plus 1 equals 0, which implies x is equal to negative 1, or x minus 1 equals 0, which implies x is equals to 1. So this one value y equals 1 also produces two values, produces two x values. One of the x values is negative 1, and the other x value is positive 1. So the final thing I'm going to do tonight is to say, when x is equals to 1, y is equals to 1. When x is equals to negative 1, y still equals to 1. So a question like this gives me 4 critical points. So when we're going to exam, we're going to get question with 4 critical points. Chances are no. In the exam, most times we get 1. Sometimes it's a mischievous, they will give you 2, but I'm yet to see an exam question that gives you 3 or more critical points. I'm only giving you this question in class so that if you were to get a question like this in the exam, you know what to do. This question that I'm doing here, that's why I never started off with it as a first question. It's going to be the most difficult question we do on this topic. I promise you on that. I don't think I'm going to give you any other question. And if I do, it's because I want to make sure that you understand it. But I know for sure for the exam, you won't get a question. Well, I will ensure that they don't give you a question on the exam paper with either 1 or 2. I don't have a problem with 2 stationary points or critical points or turning points. Don't have a problem with 2. But anything greater than 2, I'm going to tell them no, change the question. All right? So I'll stop there and ask you to classify each of those points. You have 4 points, and you're going to classify those 4 points for me. You know the formulation, and that will be the end of the question. You know the formulation. F of x times f of y minus f of xy all squared. I have 4 points, and you are going to classify each of those points for me for next class. Any questions?
Are you gonna send off this document to us tonight?
I can send it off for you tonight.
All right, I appreciate it.
All right, big up yourself. All the best, guys. Can I look out for it in a few minutes for me, please, here?
Okay, sir.
All right, cool. All the best, guys. Take care.
All right. Yes, sir.
Mhm.